Hello everyone, welcome to the most comprehensive preparation platform for all competitive exams, BYJU'S Exam Prep, and warm welcome to the BYJU'S Premier League. All dear GATE 2024 aspirants, join quickly and mark your presence. Whoever have joined, kindly confirm, am I visible and audible to you clearly or not, so that we can start this session. And today in this BYJU'S Premier League, we are going to discuss another important concept which is a frequently asked concept in the GATE exam, that is cyclic redundancy check, CRC. Okay, so guys, join the session quickly and confirm my visibility and audibility. Is this clear? So let us learn first what is this CRC, how it is helpful for error control, and then we will practice on the same topic on our BYJU'S exam prep app. Okay, so let me start the session with quick introduction of mine. I am Satya, research scholar with 15 plus years of teaching experience. I have mentored more than 40,000 students all over India in the GATE and PSU categories. I am qualified in GATE, UGC NET, SET, and also certified by Cisco into networking and programming. So this is quick introduction about me, dear friends. Guys, on 27th June, that means tomorrow, our favorite Richa Gupta madam, who has pursued her MTech from NIT Raipur, she will be conducting a live interactive workshop. In this workshop, madam will share strategy to be in the top 1% in the GATE 2024. So how you can be in the top 1% in the GATE exam, in the GATE result, madam would be giving you tips and tricks. So this workshop would be free workshop on our BYJU'S exam prep app on 27th June at 7:30 p.m. So kindly register and attend without fail. Okay. So guys, I would like to inform you that this session will be followed by a practice session on our app, on our BYJU'S exam prep app. So if you have not downloaded it, please download app and be ready for the practice session. So when we need to discuss about CRC, let us recall once about the data link layer functionalities. Data link layer, which is a layer 2 of either OSI or TCP IP model, it is responsible for node to node delivery within the network, physical addressing, flow control, error control, access control, and framing. So these are the major functionalities of data link layer, right? In this, today our topic will be error control. Error control. So already as a part of Hamming code yesterday we have discussed what is an error. So let us quickly recall once. When we say error, when the transmitted content and the received content are not same, then it is said to be erroneous. And there are two types of errors: single bit error, burst error. Means more than one bit change, that is burst error. If there is only one bit change, that is single bit error. Now, to handle these errors, there are two types of techniques. They are error detection code, detection and correction code. What are they? As we have already discussed, VRC, vertical redundancy check, LRC, longitudinal redundancy check, CRC, cyclic redundancy check, and checksum are the error detection codes, while Hamming code is the error detection and correction code. What is the difference between detection code and correction code, dear friends? Detection code will find only the presence of an error, but correction code can find the position of it also, right? So today we are going to learn this cyclic redundancy check. Yesterday we have already learned and practiced Hamming code. So by chance if you have missed it, please watch this Hamming code class which happened yesterday. Okay. Now, what is CRC? What is the CRC? Before we learn what is the CRC, guys, CRC is a detection code. While correction code find the presence and position, CRC is not a correction code, it is only detection code, isn't it? So in the detection code, we can get only the presence. Now the strategy behind any error handling code is, if the sender wants to send a data word, for this data word, some parity bits or check bits or redundant bits, maybe 1 bit or more, will be appended so that code word will form, and the transmitted one is code word, not the data word. Sender wants to send data word, but sender will send code word by appending redundant bits, right? So code word will be data word plus redundant bits. Now, how the CRC happens at the sender side? Let's see. In CRC technique, a string of n zeros appended to the data word. And what is this n? This n number is less than the number of bits in predetermined number, that is called divisor. So if the divisor is n plus 1 bit, then we append n bits zeros at the sender side. To what? To the data word. Now, once you append, what you do? This newly extended data, means after you append zeros, that is divided by divisor using a process known as binary division. Means a kind of XOR operation we do. Then when you divide, we know two results will be obtained. One is quotient, other is remainder, isn't it? So here we require remainder, guys. The remainder that is generated from this division is called CRC remainder. Now this CRC remainder replace the early added zeros. We have added zeros, no? N zeros if divisor is n plus 1. So the CRC remainder replaces this appended zeros. That is what code word. That newly generated unit is sent to the receiver. This is how sender calculate the remainder, append and send. Okay, now how receiver apply this CRC technique? Let's see. The receiver receives the data followed by CRC remainder, right? So in the receiver received one, what receiver receives? Code word. Okay, it may be with error or without error, but receiver is receiving code word. That means remainder is included in that. Now receiver will treat this as dividend and apply the same division process, but the rule is same divisor receiver is supposed to use. This is a very important point. Means what sender what divisor sender used, same divisor receiver uses. Now you will get a doubt, sir, how the receiver know what divisor sender used? Guys, while establishing the connection, protocol makes an agreement by sharing few parameters of both. So while protocol establish this connection, this divisor that has to be used will be shared. In that way, receiver know what divisor sender followed. Okay. So receiver also do the same binary division if the resultant of this division is 0. That means no error. Data is accepted. If the result is non-zero, that indicates error. So discard it and ask for the retransmission. Right? So if the result is non-zero, that means data consists of an error, so the data is discarded. How many errors? Where that error is? That is not CRC job. What is CRC? CRC is a detection technique, error detection technique. So its job is only to tell whether the received one has an error or not, whether the error is present or not. That's it. Right? Now, one important point, another important point is that divisor is expressed in polynomial form. The divisor is expressed in polynomial form. Sir, what is polynomial form? Yes. What is polynomial form? Those who have joined, kindly respond. What is polynomial form? Okay. Fine. Not an issue. Let me tell you. Give me a moment. Okay. The polynomial form means, dear friends, let the divisor is 1101. Okay. But it is never represented as 1101. How it is represented? See, 1 into x power 0, 0 into x power 1, 1 into x power 2, 1 into x cube. That means it is represented as x cube plus x square plus 1. So let the divisor function be g of x. So g of x is represented as x cube plus x square plus 1. This we will convert to binary. Understood? Okay. Now let us solve one example how this CRC works. We will know. Let's say this is the original data sender wants to send and the divisor is 11011. So what sender do? Firstly, sender append zeros. How many zeros? This divisor is having 5 bits, right? So 4 zeros append to the data word. So 1 0 1 0 1 1 100. This is what the actual data word. For this, to calculate the remainder, append 4 zeros. Now, perform division. How? 11011. This is the divisor. Division means, dear friends, remember, perform XOR operation. What operation? XOR operation. So it would be 1100111011110. Now when the MSB is 0, we will discard it and then borrow a bit from the dividend. Repeat, 11011. 00110. Now the actual algorithm will shift 1 bit only, but here to save the time, when you have multiple MSB zeros, make sure you are having those many bits to borrow. If so, you can straight away discard them and borrow these 2 bits. 11011. 00001. Here 4 zeros you can see. Do we have 4 bits to borrow? Yes. So, yes, you can neglect these and 4 zeros you can straight away borrow. 11011. 01011. Now, one MSB 0 is there, borrowed. 11011. What do you get? 01101. The MSB is 0, discarded. And do we have any bits to borrow? No. So here it ends. So this 4 bit remainder is called CRC remainder. So what is a CRC remainder? 1101. Then what would be the code word? Means that has to be transmitted. It is 101011100. Replace this remainder with the appended zeros, that is 1101. So this is what the code word. Okay. Now let us say the same is received by the receiver. Let receiver received. Let the receiver received 1010 111 00 1101. Suppose receiver received the same. What is the divisor? Divisor is known to both sender and receiver, I said, right? So the divisor receiver has to follow is same divisor, that is 11011. Now how receiver know that there is no error or there is an error? How the receiver detect? Let's see. 10101111 001101. This is what receiver received. Now receiver need not to append any zeros, because for the receiver remainder is included. Just on the received content apply division. So 11011, it would be 01110. Discard this MSB 0 and borrow this one 11011 0011 0, borrow 2 bits, 1 1 0 1 1, 0 0 0 0 1. Discard these 4 zeros and you can borrow 4 bits at a time. 1 1 0 1 1. So this would be 0 1 1 0 1. Discard this 0 and borrow this 1. 1 1 0 1 1. What do you get? 0. So as you got 0 remainder, that indicates no error. If at all there is an error, obviously somewhere you will get different value, we know, then obviously the remainder would be non-zero, right? So this is how the receiver detect. Clear, guys? And for this divisor, the divisor polynomial, there are certain rules. If we need to detect all kind of errors, there are certain rules to be followed. So let's see what are those rules. First, CRC can detect all single bit errors, okay, and it can detect all double bit errors provided the divisor contains at least 3 ones. In the divisor, if there are minimum 3 ones, then CRC can detect all double bit error, means 2 bits modified, it can detect. CRC can detect any odd number of errors, means 1 bit changed, 3 bits changed, 5 bits changed, like this. If there are any odd number of bit errors, then CRC can detect, provided the divisor is a factor of x plus 1. That means it should be divisible by x plus 1. Then it can detect all burst errors, means multiple bit errors of length less than the degree of polynomial. Like if the polynomial degree is x power 4, then up to 3 errors it can detect. If the polynomial degree is x power 7, 6 errors it can detect. Okay, and it can detect most of the burst errors with a high probability. CRC. That's why CRC is used in the lower layers like data link layer. Ethernet standard uses CRC, right? So that is what about this CRC technique, guys. Let us quickly, everybody, join now the app session. Now we will be going to practice on the same CRC, on the same CRC. On our BYJU'S exam prep app now, guys. So you can just open our BYJU'S exam prep app, and if it is the first time, please register yourself with the number, mobile number or email ID, and there under free classes you can see the class error control CRC. Also you can watch, you can find the other classes that we are providing for free. Okay, so quickly join, guys. The practice session will be there on our BEP app now. Now at 11:30 I can say, means in more 5 minutes this class, practice class would be live. Okay, today. That is 26th June So kindly join and let us practice there the CRC topic. That's all for learning of CRC. I hope you all learned CRC and understood this topic with this class. If so, please do like, share and subscribe to our BEP YouTube channel and enable the notifications. Okay guys, let's meet on our app with the practice class quickly. Chalo.